All right. So I'm reviewing a book that was written earlier this year, 2021. It's by Bill Gates, and there are 256 pages in the book. Um, it has black and white images here and there, which I've used, most of which I've used. And so any that you see in color are ones that I've added to amplify or give a different point of view. His subtitle, The Solutions We Have and the Breakthroughs We Need, I think is a good one, because so many times when people talk about climate change, climate disasters, and so on, they haggle over causes, emissions, and they don't come up with many solutions. And Bill Gates has the maturity and experience, I think, to do that pretty effectively. I have a little bit of an argument with him about how he defines breakthroughs. We'll talk about that as we get along. I do have 62 slides this morning. I'm going to give this talk twice again over the next month, and I'll scale those down. So you're to down to 32 or so. So you're getting the full tilt, and we might go a little bit past 11 before we start the question period. I hope you don't mind and can save your questions. Before I get to any of Bill's slides, I'd like to mention now the importance of the air above us. This is what's so crucial. This is a view of the Mauna Loa Observatory in Hawaii. You can see it's up on top of a large volcano above the clouds. And so it's able to take regular samples of the air and measure the amount of carbon dioxide. We'll have a picture of that next time. But something that was rather new to me and might be new to you as well is that besides the not common knowledge that nitrogen and oxygen make up 80% and 20% of our atmosphere respectively, I hadn't really thought very much about the fact that these are diatomic molecules. Nitrogen and oxygen don't like to just drift around as atoms, but they hook up with a like atom, and they're called homonuclear because they don't hook up with other atoms, just with themselves. As a result, those two molecules, we should call them now, are rather interesting and unique in that they do not interfere with infrared, or that is heat, transmission from the sun. And it will pass right through them. They have ways, which I don't understand, of vibrating in such a way that this infrared just goes in and out, and it doesn't make any difference. But compounds made up of differing atoms, such as what some people call dihydrogen monoxide, is a joke, which is of course water, methane and CO2. These are greenhouse gases, and we'll talk a little bit more about their qualities of greenhouse gases, but they are important ones. And when people talk about CO2 emissions, if they do it well and have good data, they will include methane, nitrous oxide as well, which are more powerful in their interfering with the infrared transmission. But fortunately, they don't last in the atmosphere as long. And of course, water, we have water vapor in the air all the time, and it just stays around for a couple of days and drops out as rain. And so that's part of the water cycle, and we don't think about that as a greenhouse gas, but it is one all the same as steam. Methane, of course, has a half-life of a few decades, and so it's a more powerful greenhouse gas than CO2, but because it only hangs around for a few decades, it's a problem now, and will be this century. But if we're smart, we will cut back on it enough that it won't be a serious problem. CO2, though, lasts for hundreds, if not thousands of years, and that is a serious problem. And we can do all, there's all this wonderful ballyhoo right now going on from Scotland and the COP26 meeting that we're cutting our emissions. Well, that's fine, but that can go on for hundreds of years, and we will still keep increasing our emissions unless we get to zero. And that's what this book is all about. And that's why I salute Bill Gates in emphasizing that. It's something too many of us don't understand. I should mention also, before I leave this slide, that CO2 is emphasized as early as 1896 by a rather well-known Nobel Prize winner from Sweden, a physical chemist by the name of Svante Arrhenius. And he warned us back then that CO2 has a potential to be a serious climate changer. And in fact, he even made the prediction that after a few thousand years, I think he said, that the planet water will be boiled off in the planet if we don't do something about this. So he was, that would be pretty disastrous if all the water on the planet boiled off. And that has happened on some other planets, I believe. So it's something to pay attention to and give credence to Arrhenius's insight. He got a Nobel Prize in 1903, but not for that finding. He did quite a number of other things about the physical chemistry. Now, this is where I'm leading with that last slide. This is what's called the Keeling curve. And it was started in 1958 by Charles Keeling. He was hired by the Scripps Institute to measure the CO2 concentrations at the same place and time every year. You might wonder why it's bumping up and down. Well, Hawaii was in the northern hemisphere, and so there are enough vegetation on Hawaii in the northern hemisphere for it to have a increase during the summer I beg your pardon, I guess that would be in the winter of CO2 as vegetation decayed, and then a decrease in the summer as photosynthesis took up the CO2. You can see that it in 1988, if you look across that plot, halfway between 85 and 90, James Hansen from NASA warned that our Senate, the levels above 350 parts per million, which it was back then, would lead to regrettable changes in climate. And now you can see in 2021, we're up to 413 parts per minute, particles per million, sorry. We actually got up to close to 420, I think, at one point, but we pop up and down a little bit seasonally. Anyway, we wish that we had acted sooner, back when James Hansen brought this to our attention. The title I have put on this slide, "We Haven't Been Doing So Well." That comes from George Clooney, who acted and produced a movie called Midnight Sky. And it was supposed to take place in 2049. I didn't enjoy it very much as a sci-fi. I thought there was too little science and too much fiction. But I was amused at that point in the movie when he was talking to some colleagues under desperate situations, and they were asking how things were doing on the Earth, and he said, "We haven't been doing so well." I think we'll be saying that for quite a while as we continue to look at these Keeling curves. We need to get working on it. The sooner the better. This does come from Bill Gates' book, and I just love this cartoon. He introduced me to David Foster Wallace, who wrote Infinite Jest. I didn't know about this individual. He's quite famous, died prematurely 10 years ago. But he tells this joke. He told it to Kenyon College, I guess it's called, in Ohio, the graduating class. He told this joke about two young fish who meet an older fish going in the opposite direction. And the older fish greets them with, "Morning, boys, how's the water?" And the two young fish continue swimming on. And after a while, one young one says to the other, "What the hell is water?" Like fish in water, we don't notice the fossil fuels that we use or swim in all the time. And I think David Wallace had a very peculiar sense of humor that appealed to a lot of people. In this particular joke, I find quite appealing. And so I include it a little out of sequence, but now as a fish story with a point, that our fossil fuels are like water. This is one of the earliest slides in Bill Gates' book, and it's why I like the book so much. We need to know two numbers about climate change. How's that for keeping it simple? 51 billion is the number of tons of greenhouse gases, or the CO2 equivalent thereof, that the world adds to our atmosphere every year. This is a bit of a superfluous addition, but it might give some help in conceiving 52 billion per year. If you put it into per second, it still comes to 2.6 million pounds of CO2 every second. The second important number is zero, and that's what we need to aim for. That Keeling curve is going to keep going up until we get that to zero. You hear the term a lot these days, net zero. Doesn't cut it. What we need is real zero. And this sounds difficult, he says, because it will be, and I've emphasized that. Every country must change its ways. If not, climate change's impact may be catastrophic. And that's his word. This book suggests a way forward, and that's what I really like about the book, besides these two simple numbers. I'm going to come to the corner here in the lower left. This has nothing to do with Bill's book, but I found this a few weeks ago, rather current event. It says that 4,000 tons of carbon dioxide will be removed annually from the atmosphere by the world's largest carbon capture plant, which began operations last week in Iceland. I've visited Iceland. I imagine many of you have too. It's a pretty amazing place, and they have a lot of geothermal energy. And it's an ideal place to do this carbon capture because they have all this geothermal energy available for powering such a machine. And they have basalt very closely available. After all, it is an island that's popped up in the mid-Atlantic ridge loaded with basalt. And you can pump the CO2 down in this basalt, and it will chemically bond with the basalt and turn it into various carbonates that are stable. 97% of it lasts for years and years, decades. It turned out in various other tests. And so, of all places on Earth, it would be a good place to build such a plant. But we shouldn't lose sight of the big number at the top, 4,000. If you divide 4,000 into 51 billion, they're both in tons, you will come up with 10 million. And that's the number of similar plants that have to be installed in Iceland if you were to remove all of the CO2, or most of the CO2 that we have allowed to accumulate there. I don't think Iceland would welcome another 10 million plants on their island. So obviously we're going to have to spread that out, and obviously it's not going to be feasible to scale up that high. But it's interesting nonetheless, and I think sooner or later we will find some proliferation of those plants that have already started, or that plant that has already started in Iceland. I think it's something that we should keep in mind and plan for, because we can't do it all with prevention, not the way we're going. Okay, here is the first one of his other slides. First, the point, he says, to avoid a climate disaster, we have to get to zero. I've made that point already. Point two, we need to deploy the tools we already have, like solar and wind, faster and smarter. I think it's regrettable that he didn't say include nuclear. Quite regrettable. And I think he's pandering to forces that might take him less seriously if he added it. It's unfortunate that nuclear is still a nasty word. I just got an email from Alex Canara today, and I can send it around to some of you. It's an article in the American Association for Science's journal Science, in which they have obvious negativism about nuclear, and they refer to it as nuclear technology, where they clearly include weapons and civilian energy production in the same phrase and give it all the same negativism. So I would have to give, I have a friend nearby who said he gave the book a B because he felt it was too depressing. I give the book an A minus, and I take off from A plus to minus, mostly for that reason, and others that I'll comment as we go along. But I do congratulate Bill for writing what I think is a superb book. I've been reading a lot of climate change books over the last decade, and I thought this one really made me think more deeply than any of the others I've read, and appreciate the challenge more than any of the others have. Lastly, he says we need to create and roll out breakthrough technologies that can take us the rest of the way. That's certainly true. I've referred to carbon capture as one breakthrough technology, but I don't think it's going to be scalable very much. He's obviously thinking of batteries, he's thinking of cement and many other things, and I agree with him fully on that. He probably would put nuclear in the breakthrough category, but I would not. I would regard it as a tool. It was discovered, after all, first built in the United States in 1957, in Russia in 1954, and certainly, in my opinion, precedes any significant amount of wind and solar deployment at that time. So it's a tool, not a breakthrough, and we need to consider it as such and use it. This interruption I'm putting in here, it came from one of you in the audience, and it's sent as a reminder to Bill Gates in COP26. It's an observation from a Swedish engineer. The notion that a nation can run on sunshine and breezes is worse than delusional. The 2 megaton windmill, most of them are 1 megaton, but they've started getting bigger lately, is made up of 260 tons of steel that requires 300 tons of iron ore and 170 tons of coking coal, all mined and transported and produced by hydrocarbons. His last statement shook me a bit. I didn't realize it was quite this bad, but it probably is. A windmill could spin until it falls apart and never generate as much energy as was invested in building it. That's a remarkable statement. The fact that it says could spin doesn't convince me that it happens to all or most, but it certainly raises the question. The photograph also came from one of you in the audience. The one on the left, the one on the right, is one that comes from Getty's images, and that's how the wind turbines should look like. I've flown my ultralight right near one of these. You have to be careful not to get caught in the drafts. I always wanted to take a picture of one myself like that, but I was too busy keeping free of the blades to hold my cell phone up seriously enough to take a good photograph. So I have to use that one from the web. But to a pilot, they're beautiful. I don't think every pilot feels that way, but I do like to see them in the environment, but they do take up a lot of space, and we'll talk more about that later. We need to move on to David McKay. He's a very famous guy, now deceased. I met one of his sons recently in Madison, or not too recently, about 10 years ago. A delightful guy who's known for back of the envelope or napkin calculations. And he, along his way, he's written some wonderful books that I recommend highly. But this is a book relating energy use per person some 7 years ago with income per person back in 2014. And the whole point of this is that there are a lot of us in these upper right-hand corner who enjoy the benefits of income, and because we have a lot of energy and we can invest things through the use of cell phones and many other things so that we can have a high income. Then there are a whole bunch of people here. This is a log graph, by the way. And so in this middle zone, there are a lot of people here: Colombia, India, the Philippines, Ethiopia, Kenya, and so on, Haiti, that would like to be like us. And some of them will never make it, but some of them will. Enough of them will that they will want and will use more and more energy. President Biden today said in Scotland that he's going to give, I think he said, $3 billion a year to various disadvantaged countries like this to help them deal and adapt to climate change. While they're adapting, they will hopefully, they will certainly use more energy and have a bit more income. The side notes under David McKay read, energy is crucial for lighting and refrigeration. Those are two ways to eat properly and study in the evenings. And the subtitle again is in red, we should provide more energy for the poor, but without releasing any more greenhouse gases. Well, it's hard to do, but Bill is thinking about it and realizing that people like, I think we have a guy, momentarily blocking on his name, out in Stanford, a professor out there, who says we can do it all if we don't use so much energy and just rely on wind and solar. Obviously, he isn't thinking seriously about all these countries in this middle zone who are going to want to have more income and use energy, hopefully wisely. And we are, after all, we make up a 25th of the world population, and yet we emit a quarter of the world's CO2 or their equivalent. And so it's not fair for us to be so energy release dense and deny that to the other countries, the way this Stanford professor seems to have done. So now this also comes from Bill's book. He says 3 lines you should know. These lines show you how much the temperature might go up in the future if emissions grow a lot. That's the high line in solid, very solid line. If they grow less, that's the middle or lower line, he calls it. And if we start removing more carbon than we emit, we hope that will happen soon. So here we are, a little after these data were made in 2017, and he's projecting these 3 possibilities starting about now of these 3 diverging curves. I'm a little dubious that we'll do the negative one, but it sure would be nice to do the middle curve instead of the high curve. This is in degrees of rise, and we don't have good data on that. We have better data on what happens to the global average temperature if we lower it by 6 degrees. We have about a mile of ice sitting on top of us here in Wisconsin. If the temperature went up 4 degrees, if we go back to in the millions and millions of years, there were crocodiles in the Arctic at that last time that we were 4 degrees warmer. So the planet has gone up and down a bit over the eons, and 4 degrees would certainly make a big difference. Would not necessarily wipe us off the planet, but it would make life a lot more difficult for us to adapt to. This is another interesting talk, pair of slides on the history. He mentions that CO2 and CH4, that's methane, are serious greenhouse gases, but we're thinking here mostly for reference of carbon dioxide. And you can see historically the global emissions started around pre-World War II in the 1930s and 40s, and really ramped up. I remember as a kid in 1950, I was just 12 and had no idea about this particular problem, but life wasn't really all that tough in 1950. I think it would be tough to go back to that, but I think we could think a little bit more about what life was like back then, and maybe not be so demanding of using energy intense things if we're thinking as a species instead of as a tribal unit, which is what we're doing so far. By the way, thinking of tribal units, some of you may have seen the 60 Minutes last night comments about artificial intelligence. And that was a fascinating interview in which the question of how we must become as a species rather than a tribal unit, and that applies to energy as well as artificial intelligence. On the right, the usual temperature score, and you can see we have gone up from the baseline of 0 by about 1.25 degrees centigrade, not Fahrenheit, but centigrade here. And so that's significant, and we should think in terms of centigrade because that's where most of the data are coming from. And it will be an important marker to follow. He then goes on and makes some predictions from the world's building stock. I'm not familiar with that, but they make a prediction that by 2060, the world will be building the equivalent of another New York City every month for the next 40 years. People can make these predictions all they want. I'm skeptical of that. It's a fascinating photograph. And to imagine every month another New York going up someplace in China or Asia or Indonesia might happen for a while, but I'm not convinced that it'll happen for the next 40 years. I hope not, because that is certainly, as he says in the next slide, putting up more city buildings is good for city dwellers, but bad for the climate. Global energy demand will rise 50%, he says, by 2050. Even if the rich world could get to zero emissions by then, the ROW, that of course stands for the rest of the world, will be emitting more and more. You can see the emissions per year on the left panel. China soaring up. Emissions per person looks kind of good. The United States and Europe coming down, as they mentioned at the COP meeting today. But in China and India, it's going up. Representatives from China and Russia are hard to come by today in Scotland. Bill asks the question, can we learn from history how to solve this dilemma? And he comes to this graph next. And I'm not sure that he's learned very much from history. Obviously, coal was a winner for 60 years, and global energy supply increased dramatically in those 60 years, 1840 to 1900. Oil did almost as well. It allowed us to cut back on our use of oil. We've seen that in many graphs from 1910 to 1970, and natural gas the same from 1930 to 1990, where gas pipelines have been used to heat many homes. And then he's got modern renewables down here, and of course he doesn't predict, nobody can, but knowing how inefficient renewables are and how difficult they're going to be, and we've talked about that last time in Climate Gamble, I can't imagine that they are going to exceed much beyond 10%, maybe 15 at most, in my opinion, as a global energy supply. Now, 5 questions, he says, to ask anybody who comes up with a bright idea. First is, how much of the 51 billion tons are we talking about with your fancy idea? What's your plan for using cement? How much power is required to drive your idea? How much space do you need? And how much is this going to cost? They're all very good questions. I couldn't help but throw in here a table that I show every time I have an opportunity to show slides. It's from Professor Wade Allison's table, and it shows what he calls in the central column chemical electronic. What he really means to say is oxidation of organics. And he shows that the energy density, the middle row there, is 1 to 7 for that group. Renewables, again, perhaps when you consider what was just revealed about wind turbines, he gives it a pretty low energy density when you think of the energy used to make the darn things. And the energy that comes out, the net energy would be in kilowatt hours per kilogram. He does give it a number, not a positive number, but it's 4 logarithms lower. Whereas nuclear is 7 logarithms higher. And therefore, it should not be the N word, the forbidden N word of energy. It should come into discussions openly, both in Scotland, which is not happening yet, I don't think much today, but all through the world. Anyway, we must zero out all 5 of these. And this, I think, is the most important slide of the series and the most important table in Bill's book. How much greenhouse gas is emitted by the things we do? He puts making things at the top. We've been accustomed in the past to taking what we call the low-hanging fruit, which is the second one, plugging in electricity and getting around. I will comment that these numbers don't necessarily agree with everyone else's that I've seen. Last week we heard from Alison Duff about growing things, and she put that number, I think it was a global number, at 10%, and here he's put it at 19%. I'm a little more inclined to believe Allison than I am Bill on this number, and I think that making things might not be quite so high. Plugging in, I think, is probably accurate, and getting around, I think Bill underplays that. I think 16% is a little low. Many people put that closer to 26%. So it's possible that items 3 and 4 are overplayed in growing things and underplayed in getting around. But Other than that, I think it's a good working model to make us realize that making cement, steel, and plastic is a tall order and much harder to correct than the relatively simple, although still challenging things like electricity and transportation. To start with electricity here for a moment, this is a useful table. I like it because it helps us to think in these terms. A watt, of course, is a joule per second, so it's a rate of doing work, and that's what energy is. And when you take an average American home, we will go through probably, we're using at any given moment 2 or 3 kilowatts. And it varies, of course, different times of the day. And you can see that on your electric bill. But that's a useful turn to have. I have 2 kilowatts of solar panels on my roof, and I know that they only cover a bare third or a quarter of my energy use when I have my swimming pool turned off in the 3 months of the summer. So I can relate to that. Small towns use in the order of megawatts. So if you have a 1 megawatt wind turbine, you could power a small town. A mid-sized city would need a gigawatt. That's, of course, 1,000 megawatts. And that's a typical energy level for a nuclear plant. United States as a country would go through somewhere in the neighborhood of 1,000 or more gigawatts. In the world, about 5,000. So those are interesting statistics and worthwhile remembering. On the right, I've just shown the difference between two types of power and energy. You can have the cup forcing out a lot of water, generating some kinetic energy, or you can have on the right a big jug which holds the potential energy, and that can come out. So we have to think of energy in those two roles. Bill also has this table on the left. How much land does it take to make electricity? Actually, Bill's numbers are a little different than that. He has how much energy per square meter, and he has the fossil fuels and nuclear at the top, and then going down, which is worthwhile noting. The American Nuclear Society has this different way of looking at it with the blue background, and they have the area, or relative area, no numbers here, of that needed for a given amount of energy. So wind is high, solar a bit lower, hydropower lower, coal, which is not we don't want to think too much about coal because we want that all to shut down pretty soon. But notice nuclear is a tiny, tiny blue dot, quite different from coal, as opposed to Bill's comments there that he thinks they're comparable. I think that I'm not prepared to argue because he might be thinking of the cost of a plant, the size of a plant, and the relative energies. But I would argue that fossil fuels don't generate more watts per square meter than nuclear, as he has suggested there. Minor point. This is another important one. And you have to remember that this is global use of, as of 2020, of various forms of energy for making electricity. And you see there that coal, natural gas, the fossil emitters are making an awful lot, almost 60% of the electricity made around the world comes from these horrible fossil fuels. Hydropower makes a significant amount, nuclear 10%. In this country, it's 20%, but globally, it's only 10%. So it will take a little harder to clean up the grid because hydropower cannot be increased very much beyond where it is now, and some of them are coming down. Renewables might go up a bit. They're talking about 11% now. I'm not sure that it will go much higher. And so clearly, to get rid of these fossil fuels, we need to and can expand nuclear because of its energy density. All we have to do is stop being afraid of it and talking negatively about it. This slide relates to the United States. It's my image, but these are his words on the right. And notice that this is in the United States, not globally, and it's emission free. So you have to think back and think about the left quadrant here, renewables, nuclear, and hydropower. That's what we're talking about. And you see here that nuclear is 52%, not something to be ignored. United States sources of emission-free electricity in 2020, pretty current data. Solar 6%, wind 22, hydro 19. These are his comments. And this, he only talks about nuclear fission twice, and not much more than the 3 lines each that you see here. I've compressed it a little bit. He says, nuclear fission is the only carbon-free, reliable energy source available 24/7 almost anywhere on Earth, proven to work on a large scale. I like those words, almost anywhere on Earth. It doesn't have to be on an ocean coast or a river. It can be inland. They have them in Arizona, air-cooled instead of water-cooled. Nuclear fusion, he says, holds a lot of promise, excuse me, but still very experimental and very hard to make practical. I agree with that. Offshore wind blows more steadily, more popular in Denmark than here, where it's unpopular with tourism and fishermen. What Biden doesn't seem to know, or if he does, he hasn't said it, is that all this offshore wind he wants to put up the Atlantic coast, Denmark has already published that the median time to replace significant damage on the turbines of the blades happens within 5 years. We're not talking 20 or 24. It doesn't mean that they have to be taken down, but at least I think the median, which means within half of the group of offshore wind turbines put up, half of them will need to have significant repairs within 5 years. A lot of people don't know that, and I think that, in addition to the remarks I made earlier in this talk, indicate that we do have some limitations on wind. Geothermal, he says, requires digging deep wells. I didn't know that 40% of them of the wells drilled don't deliver well. Hydropower, we've talked a lot about. It's relatively cheap, but making a reservoir displaces people and wildlife. And we've seen how the Colorado River is disappointing many people in terms of the available hydropower out west. Solar power is hampered by seasonal as well as nighttime intermittency, requiring either energy storage or baseload grid support, and we know that well. Now, this slide I've added, it comes from the EPA, the Intergovernmental Panel on Climate Change, life cycle greenhouse gas emissions. And you can I've taken a look twice at that website. It's quite interesting to me because it shows grams of CO2 per kilowatt hour. And it shows hydroelectric at the top and nuclear third, but wind has these black lines and pink lines, or magenta. The black hatched line is backup gas CO2 emissions for when the wind isn't blowing. You come down to solar thermal, and it's even worse. Solar PV, worse yet again. And it also, of course, the leakage applies to natural gas itself, making it virtually as bad for CO2 emissions as coal is. This GWP stands for global warming potential. And to answer your question, Mert, briefly, but not in any depth, various scores are given for global warming potential, and they take into account the various greenhouse gases and make them relate them to CO2, which has a score of 1, and the other ones are higher. Methane, I think, is 35 or something like that. Nitrous oxide is up close to 100. It's much worse. So, excuse me. That's something that didn't work its way into Bill's talk, but I felt obliged to include it here. Coming back to the materials that go into these sources of electricity, we've shown this in color with other slides, but solar, hydropower, wind, and geothermal use a lot of concrete and cement, steel, etc. Nuclear comes out just slightly worse than natural gas, which I find interesting, considering how we damned natural gas in the previous slide, but it's depending on the parameter. that you get different qualifiers. Then there's the illogical fear of nuclear, and is nuclear power dangerous? He says in deaths per terawatt hour, not if you're counting the number of deaths caused per unit of electricity, and 0.07. There's some data to suggest that it's even lower than that, depends upon how you score the number of deaths and so on. But the fear, I think, is largely based on the inconvenience people found in Fukushima, where the tsunami caused a lot of dislocation, and people just attributed it to the nuclear plants because they added to the fact, and it was exaggerated, that people were delayed much longer than they needed to be, and suicide is a much more prevalent solution to social stress in Japan. So many of their deaths in Fukushima were not directly related to nuclear. People may not appreciate that. Anyway, coming to storing electricity, that's an important thing for the intermittent forms of energy. And he says it's hard to improve on lithium, although liquid metals are under study, as are flow batteries that store fluids in tanks and then make electricity by pumping the fluids together. We talked about pumped hydro before. He says the largest US facilities store less than an hour's worth of US electricity, all 10 of them. Thermal storage he's involved in. He says molten salts can store energy at 55% efficiency and can hold daytime solar heat for electricity help at night. The cheap hydrogen, that requires large storage tanks, but solar energy might be stored as hydrogen to support fuel cell batteries in the future. Talk more about that later, but those are the basic ways we might store electricity for intermittent sources. Other innovations, we've already talked a bit about capturing carbon. He says if you do it as it comes out of a coal or gas plant, it's more efficient than taking it out of our air, where it's a much lower concentration. But even doing that only removes 90% of it, not 100%, and it's expensive, and the utilities have no incentive to do it so far. Direct air capture, we talked about that more in Greenland and Iceland, I'm sorry. That can be done anywhere, but the concentration of CO2 is 25,000 times less than in our air than in a plant exhaust. That should be then. And this would require lots of energy plus save permanent storage. Using less, he does point out it will be easier to scale up to 100% clean power if we lower our energy demands wherever we can. We can also shift our demand to times of less industrial need, but we'll need to shift our policies and advance our home technology to smart use. Many of you know, most of you should know, that the suppliers of electricity do give us incentives to use energy if we use time of day. It doesn't cost us anything. All we have to do is ask the Alliant or Medicine Gas and Electric, and they will do it at no charge that I'm aware of. And I certainly have done it for years, and it's nice to do some things on the weekends that we might otherwise do during the week, and use the energy more when there's less demand. Now, Bill lives out on the West Coast in Seattle, and this is the bridge. He calls it the 520 bridge that he crosses whenever he drives from home to the Gates Foundation headquarters. He points out that this is a floating bridge. It's 7,700 feet long. It's the longest one of this type in the world, longest floating bridge. It's made with tons of asphalt, concrete, and steel, and it still floats, supported by 77 air-filled concrete pontoons. Good qualities of concrete were not lost on Thomas Edison, nor in the Chinese in the next slide. I thought this was interesting. I'd never heard of this bridge before, and I'm kind of glad that Bill referred to it. This is another one of his slides that really makes the point that in this last century, the 20th century, we used 4.3 billion tons. For each one of those bricks of cement represents 1 billion tons. And look what they did in China just in the first 16 years of this century, 6 times as much. So China makes a lot of cement. The country has already produced more than the 21st century did in the United States, more in the 21st century than the States did in the 20th. So interesting data. He says urban growth will continue with increased need for energy. We'll need lots of plastic, steel, glass, aluminum, and fertilizer. And he says steel needs alone will go up by 50% in the next 30 years. And these are 2 pictures of Shanghai, one from 30 years ago, and the other one from just 8 years ago. What a difference. Now he's going to deal with this green premium, and need to spend a little time on this. These are three basic materials here on the left: ethylene, which is plastic, steel, and cement. And there's the average price per ton. I didn't realize plastic was so expensive compared to steel and cement. The carbon emitted per ton of materials is fairly uniform, between 1 and 2 tons of carbon is emitted, or carbon dioxide. Then there's the new price if we were to capture the carbon. And that would go up by 9 to 15% for ethylene or plastic, 16 to 30% for steel, and 75 to 140% for cement. So that green premium means it's the increase in price to capture the carbon. That's how he defines green premium. We'll be talking about that all through his book. Let's focus for a moment on the cement problem, converting limestone into cement. I've done my best to make a chemical formula for this. We take limestone, which is calcium carbonate. That little upside down V represents heat, sort of a universal symbol, especially if you make it a little triangle. And so you have to heat that up and use a lot of energy, of course, in providing that heat, unless it's, well, no matter what the source, you use a lot of energy. And you make what's called lime, or calcium oxide, and CO2. So there is where a lot of CO2 is released. Making cement is the most difficult process of all to decarbonize, he says. Some companies, and he quotes Microsoft, his own, and McDonald's, inject the CO2 that's released from making the cement back into the cement itself. But he has to admit this cuts emissions by only 10% so far. And he does talk about new Hoffman green cement, or HEVA, which uses special clays and gypsum that reduces carbon footprint by 80%. That's pretty cool. To sum up, he says, use decarbonized power, and nuclear can provide heat directly. He doesn't say that, but I stuck it in. I couldn't resist. Without conversion to electricity. And that's something that I've saved for the very last slide. It's something we think of nuclear only as a source of electricity, but it can be used for heat in many industries, especially as we make micro reactors in the not too distant future. And we can use carbon capture and storage to absorb the remaining carbon emissions. This next slide is not from him. It's from a very positive sounding person. We have on the left the CO2 emissions in gigatons as of now, 2020, projecting up to 2050 along the abscissa. You can see the dashed blue line at the top, and that is a line that societies will need for concrete in the absence of any action. If we just go along doing everything else as we have in the past, that will go up from about 2.75 to 3.8 over the next 30 years. If we don't do another darn thing about cement. But he says if we use sufficiency in design and construction, I'm not sure who this is. It's a group of people, a consortium that got together and came up with this idea. They feel that you can lower it by 22%. In the actual concrete production, another 11%. Some various savings in binders. I don't know what that means. Clinker production, I'm not sure. But this is a big one. Carbon capture and utilization and storage, 36%. Wow, I hope that works. Decarbonization of electricity, I think for that they mean using something like nuclear power, which runs 24/7 and at very high efficiency, and that could drop at 5%. I would think it would be more than that, but I'm not part of the consortium. And then they want to sink the CO2 for another 6%. It's very optimistic, and some people have been quite critical and call it science fiction, but it gives you an idea of the efforts that some people are making to try to lower concrete emissions. It's a serious problem, and we do need to give it more thought and more action. Coming back to the book, we're now moving to what Alison Duff talked about last week, but Bill has a big awareness of the country, the world as a whole. He says we're raising 1 billion cows on this planet. It's a big contributor of greenhouse gases, mostly by belching ammonia and nitrous oxide, which are 28 and 265 times more greenhouse gas-like than CO2. And so that rate comes up to 4% of the 51 billion tons. That's a lot. And apparently, um, this is quite serious in China. Didn't realize that was so much higher than in the United States and the EU. You have to notice that those are predictions in the right after 2020, the darker gray in the background. So we're not sure if that will really happen. Solutions beyond eating include eating beyond meat, dieting, and wasting less. Those are from his words. Pretty much, he admits that he's been eating a lot of cheeseburgers over the years. They say that the average American eats 3 of them per week, and so he admits that he should cut back to the degree that he doesn't say. But he says most countries are consuming more meat than they used to, but China is a big exception. They're trying to catch up with us, but there's so many more people that, as a country, they're way ahead of us. This is relates to agriculture. Besides the meat, he points out something that we all should know by now. We've talked about it a number of times. Back in 1908, Haber and Bosch found how to make ammonia from nitrogen and hydrogen at high temperatures. This is a crucial discovery for making synthetic fertilizer and raising crop yields when people were predicting famine way back 100 years ago. However, soil microorganisms stop making their own nitrogen if synthetic fertilizers are nearby them in the ground. So we need to be cautious of that. He says globally, fertilizers cause nearly as much greenhouse gas emissions as cows do. He is very aware, Bill is, of Africa, and he says the so-called Green Revolution largely bypassed Africa, where a typical farmer gets only a fifth as much food per acre as we do. And we've gone up pretty dramatically, 3 or 4-fold over the last 50 years or so. So he says, sadly, helping them, the Africans, save lives will put more nitrogen into the Earth's soil. And so it will add to our greenhouse gases. So we need to plan ahead to see if we can do it in a way that does not add more greenhouse gases. He talks about the downsides of fertilizer, and I've just tried to lift some of his keen words. He says, sadly, there is not a zero carbon alternative for fertilizer right now. Even if we use clean electricity to make it, we don't have a way to capture the greenhouse gases that come from applying it. Farmers might monitor the nitrogen levels carefully and apply fertilizers as needed, but generally applying much more, I've got it twice there, than they need, might maximize crop growth. And but would be more than they need and would just suppress the bacteria in the ground all the more. Some companies are trying additives to help plants take up nitrogen more efficiently, but so far they don't work well. Other companies are trying to make genetically modified organisms that produce nitrogen better in future, and that might help. So far, Bill says he's focused on agriculture, which accounts for 70% of our emissions from land use. But the other 30% relates to deforestation. In the last 30 years, we've lost over 500,000 square miles of forest cover on the planet. It's an area bigger than South Africa. There are many reasons for this, from making pasture land palm oil and charcoal. By the way, I got an email this morning about palm oil. They said that it's in most of the Halloween candy, but that there are quite a few companies now making candy, quite a number of them, that are using it in an eco-friendly way that have reduced by at least 50% the greenhouse gas emissions from making palm oil. And they say that it's better to do that than stop using palm oil altogether. First of all, it's very, very difficult to do, if not impossible, for the shopper. And secondly, it would disrupt the entire economy, and we might be using oils that are worse than those used for making palm oil. So it's in the news, and if I see that thing some more, I might send it around to you. Well, what if we simply plant trees? Everybody's talking about that. What a neat thing that is to do. How much carbon dioxide can a tree absorb in its lifetime? It says it varies, but a good rule of thumb is 4 tons over the course of 40 years. It's not an awful lot over quite a period of time. The second question is, how long will a tree survive? Well, if it burns down, all the carbon dioxide it was storing will be released into the atmosphere, and we do that all the time when we burn our brush in the backyard if we're allowed to. Well, what would have happened if you hadn't planted the tree? He says, well, a tree would have grown there naturally. If a tree, then you haven't added any extra carbon absorption. So he says, taking all these factors into account and doing the math, planting trees to absorb greenhouse gases for every American would cover half of our planet's landmass. We should focus on preserving the trees we already have. His final conclusion is it would take a lot of new ideas, such as eating less meat. So, how we get around. Moving now to transportation. This makes, according to him, 16% of 50 billion tons a year. I think it's more than that, probably another 10%. But here's his little quiz. Let's start with a quick quiz. Which of these contains the most energy? A gallon of gas, a stick of dynamite, or a hand grenade? Well, you think of the dynamite or the hand grenade as the sudden releases of energy, but actually gas is more powerful in terms of the amount of energy released. The second one, I'm not sure which of those is true any longer. He says when this was written, gas was $1 a gallon cheaper than it is now. And so he said that it's cheap, but demand for it will continue to grow in spite of COVID. That is for fuel. So question 2, I think, is a tough one to answer with the price of gasoline rising so fast. Anyway, future transportation emissions are going up in other low and middle income countries, as you can see on that dot dashed line there. This is interesting data to think that you have to remember that this is shaded now from 2017, shaded to the right of it. And so those are all predicted courses. And somebody seems to think that both the United States and China will come down. I hope they're right. Not convinced, but it's an interesting prediction. China, of course, they have little dots that's going to continue to rise, but will eventually taper a bit. And India will keep going up. So what they're basically saying is that most of our growth in aviation, trucking, shipping will happen in growing countries. And I think that's true. And he points out that cars are not the only culprit. He said 1 billion cars are on the road now, and it's still increasing. To electrify, we'll need cheaper batteries and cleaner electricity. Less charging time would help too. But it's not going to make a big amount of difference, I should say, if we just get electric cars and don't clean up the grid. So this is very much dependent. It's which came first, the chicken or the egg. We need, I think there is pressure as we get more electric vehicles to clean up the grid. One of the things that surprised me most about this is that garbage trucks down in the lower left, buses and 18-wheelers make up 30% of the emissions. This is not really well characterized, but these are carbon emissions here globally. And another one that surprised me a bit is that cargo and cruise ships were no more than airplanes. I hadn't thought of that. I thought airplanes was a little lower and cruise ships higher. But in any case, they're all a problem. And it's going to be tough to get nuclear reactors in our cruise ships, that's for sure. And impossible in airplanes, but we can improve it. We'll talk about that some later. Well, this is a curious little figure that Bill put in his book. He says, let's compare 2 Chevys, the Malibu and the Bolt. The Bolt is more expensive, of course, by 14 grand, so that's considerable. But the comparisons below the cars are not very meaningful. You've got mile per gallon, not very impressive, roughly 30 or so miles per gallon, maybe a bit more in the highway. And he doesn't have that for the Bolt because there's no such thing as miles per gallon, but it has a range of 250 miles, which is pretty good. I used to drive a little Beamer. I only had a range of 80 miles, but so 250 with these newer models is pretty good. The cargo one really threw me for a loop, so I wrote to a friend of mine who has one on the West Coast, and I asked him, how could that be 56.6 cubic feet? And he replied and said that that's probably because when you, with a Bolt, you can convert the back seat into a cargo area very, very simply, and just by a quick flip of the seat back. It's so easy to do that they consider that part of the cargo because there's not much of a trunk in that car. And so that's why they have such a big cargo area. But you lose 2 seats, of course, if you're going to load up the cargo. And the horsepower is comparable. So that's an interesting comparison. So how to get to zero carbon? Gas prices will influence buyers the most to buy an electric vehicle, he says. They have risen, of course, since last spring, so that may be even more of an influence. Another drawback is having to spend an hour or more to fully charge the battery. But if you live at home, this is the key. It's very easy to simply plug it in when you get home. And if you can time it to when the sun is shining and you have solar panels, so much the better. But if you want to time it to better times of day for your cost of electricity, so much the better. But he says, if you can't do that, what about various fuel types and the retail price per gallon? Well, you can replace those basic fuels with what are called advanced biofuels. Now, we are already doing that. 10% of it, and most of us, we're buying our gasoline it's 10% ethanol. He criticizes that appropriately because taking it from corn is just a boondoggle for the farmers and raises the cost of other foods more and reduces its quantity. Not a good idea. But so when he says advanced, he does not mean ethanol from corn. He means to advance it beyond that to switchgrass and other waste vegetable matter. And if you do that, you can more than double the cost of the gasoline, in his opinion. If you use electrofuels, that's called green hydrogen. Now, regular hydrogen that we make from stripping the hydrogen off of methane, 4 atoms per molecule, is called gray hydrogen. There's also green hydrogen done electrically, usually with nuclear power or some other readily available source. Some people would use solar, although I think it's not very efficient. But in other words, you use electrolysis. And you can also, some other forms of hydrogen are called blue hydrogen. And then there's yellow hydrogen and magenta hydrogen. They're all different kinds depending on how you make it. But so I think he's throwing it all in as electrofuels. And they are expensive. He apparently uses them in his jet airplane. And so he does, that's why he's quite interested in electrofuels and makes a point of learning about it. He comments also that in China, they are doing a few good things. They've electrified their fleet of 16,000 buses and 2/3 of their taxis in this one city. I don't know about other cities, but he only gives that one. I thought that's a fascinating image to make the point home. He says, while our best batteries have 35 times less energy than gas, buses that stop frequently can regen their batteries as they coast to the next stop. And the regen feature, most of us know who drive hybrid cars, you really feel it when you're driving a Tesla or most any other kind of pure electric vehicle. You feel a definite drag as you're sitting in the car once you take your foot off the gas because you're recharging your batteries and it's giving you a nice boost to the battery duration. But those buses would do that wonderfully well. Consume a lot of energy to get going, but they have a lot of momentum once they do, and with the frequent stops, they can regen a lot of that energy. Well, diesel fuels, long distance trucking is a big problem. For one electric truck, people have been talking about that in Los Angeles if they're going to buy a bunch of these Tesla trucks. They say they can go 600 miles on one charge, but they would have to carry 25% less cargo in order to hold enough batteries. These haven't been made yet. They're on the drawing table. But he says electrofuels would have dramatic green premiums, and maybe we should think about using rail more. So you can see those green premiums there are pretty remarkable for diesel. Aircraft will be harder. He points out that whereas here, 234%, here we're up to almost 300% for electrofuels, and he's very aware of that with his jet airplane. He says it's very expensive. Maybe we should fly less and zoom more. Boy, I sure agree with that suggestion. I've just put in an extra slide here to show you what they're doing in the aviation industry because I follow a lot of this. On the upper left, you have a fairly conventional six-seater aircraft or eight-seater that has batteries installed, and it's a hybrid. And so it can use more electric energy from batteries that are recharged with hydrogen, as well as internal combustion. And those are being studied with just conventional airplanes. To the upper right, they've got this jazzy picture taken over some wind turbines, probably on the California coast. And it shows a push me pull you. You can see that if you look carefully between the twin booms, there's a pusher motor there with an air intake for it over the top of the fuselage. And what they can do is use two engines to take off, shut one down, or feather the prop so it's not dragging, and cut back and use battery power for crews at much lower power settings. And you could have 6 passengers in a plane that size. There's a little baggage pod underneath the fuselage. So it's a nice idea that can be advanced and promoted. There's some really nice ones. One called Alice, ALICE, that's quite interesting if you want to look it up, Google it up. Down in the lower left, we have Air France using Total biocarburant. And this is taken from a variety of sources. Some of it's they use try to remember the biofuel. Anyway, they use various sources varying from fungi and seaweed and various other things that can generate diesel fuel or electrofuel, which not diesel fuel, but jet fuel. Sometimes jet fuel is a little easier to modify than diesel fuel. And Air France is trying it out with a big company there in France called Total. And on the right, you have an Airbus. This is rather interesting design. They're coming to the conclusion that passengers who fly in conventional jets don't bother to look out the window anymore. Most people just put down the shades and watch the television in front of them. And so they've decided not to bother putting in passenger windows. And they have their electric motors of the future on top of the wing. They've also discovered that putting power on top of the wing will improve the Bernoulli effect. That is the higher speed, lower pressure over the top of the wing. So by incorporating the passengers into the wings on either side, you can have, I'm not sure what the passenger capacity of that is. It's just a sketch of a 0E Airbus, but that they would like to make it pure zero emissions, I guess, at Airbus in the hopefully not too distant future. It's intriguing, and I'd like to know more about it, as you would, I'm sure. Getting back to the text of the book, shipping will need nuclear. That is not his, those are not his words. Those are mine as a conclusion. But she says shipping alone accounts for 3% of all carbon emissions. Bill doubts we can change that much. This is my phrase, but new container ships from Korea are thinking about becoming nuclear. And that excites me greatly. I don't know if any of you have seen, but at the there's a neat place. I think many of you were invited to do a little field trip to a place on Femright Avenue here in town, named after a famous ecologist. And we saw maps, global maps of the ships around the globe, and it's incredible. The number of ships steaming around with their bunker fuel, and look at those prices. If they used on electrofuels, it would be a 600-fold or 600% increase or a 6-fold increase in the cost. So that's why I say we need to get nuclear ships. Other transportation solutions, of course, many of you are doing this already, and I think it's wonderful. Less driving, less flying, less shipping, more walking, biking, and carpooling. We need to lighten our vehicles and cut carbon intensity of manufacturing. Momentum is is a huge factor in cutting back emissions, as people have found in the hybrid car industry. Raising fuel efficiency standards, of course, and lower the green premium, have better government policies, cheaper alternative fuels, and better ways of making hydrogen. So true. Now he talks about air conditioning and our need. He says that this is an interesting graph. It shows that 10 countries, and the top 5 are Japan, United States, South Korea, Saudi Arabia, and China. And the bottom 5 are much more tropical than the top 5. And so they're going to need air conditioning, and they don't have it yet. And that makes a very powerful point that they're going to want it. They're going to want to be like us, and those numbers are going to go up for sure. Air conditioning is needed for our computers. Air conditioning uses more electricity than our lights, fridges, and computers combined. Now we're talking electricity. If we broaden the qualifier to energy, then of course furnaces and water heaters use more energy because they're powered by methane. And that's going to be a tall order to convert those to electricity, as has been suggested by Robert Hargraves, but hopefully it will happen. How about a heat pump? This is an interesting question. And he has the cost for 4 cities in the United States, cost of natural gas furnace and electric air conditioning. That's what those people in those cities pay on the average, and the cost of an air-sourced heat pump and the green premium. These people, according to Bill, would have a negative green premium. That is, they would save money. And the people who would save the most money would be in Houston, Texas, where it's a heat pump would be able to provide heat for the house in that mild climate much better than in Wisconsin, and wouldn't need to have anything much more than a heat pump in some homes, perhaps if they're well insulated, and could cool you in the summer as well as heat you in the winter. So those are interesting ideas. Then when you come to heating oil, you can see some big green premiums there on the right, particularly if you're using electrofuels for heating oil and for natural gas, way, way up. Green premiums are really worse there. Well, he talks about the Bullitt Center. I'd never heard of it. I went up on he had a picture of it in his book, but I went on the web and used that picture instead. But it's a dramatic building. It's designed in Seattle to naturally stay warm in winter and cool in the summer. It makes 60% more energy than it consumes, utilizing good insulation, triple glazed smart windows, and efficient doors. There are 575 solar panels up there on the roof, as well as geothermal warming and cooling from 400-foot wells. This I think is the coolest point. So many of us design buildings that last for 40 years. This was designed to last for 250 years. I hope it does. Anyway, in summary, this is a complex problem that needs lower green premiums in every sector and lots of inventing. Good point. Okay, we're coming near the end, believe it or not. It's a 11:15, so I hope you're hanging in with me. Here are 3 stages of what will it take to adapt. We're not talking about mitigation now. We're talking about adapting here. We need climate-proof buildings. We need to protect our wetlands, encourage relocation as needed. That's a biggie. It's going to cost a lot to bring people in from the coast, particularly Florida and Louisiana. To prepare for emergencies with better early warning systems. We've seen that with tornadoes happening in the Southeast, the need for that. We need to provide services for displaced people. That's happening on a volunteer basis, as well as through some government agencies to date. There are 4 big headlines. Coastal cities must change the way they grow. Interesting thought. Miami comes to mind. Shore up our natural defenses, and this is the arrow pointing to these magnificent trees here, mangrove trees that help to protect the shorelines. Provide reliable drinking water. I remember when the head of Oak Ridge offered to provide a nuclear plant that would desalinate Pacific Ocean water for Los Angeles and the surrounding communities and farms north of there. They turned him down. But I think they wish they hadn't now. If they could have had that offer, they may yet save Diablo Canyon and hopefully build some desalination plants in for the farms of California, so they don't need to draw so much water off of the Colorado system. They need to unlock more new money by screening projects for climate risk. I think he's very aware of that. Sometimes I think he's applied for money for that purpose himself. Okay, we need government action too, and he has a whole list of these. Find the investment gap. He says energy companies spend 3% of the revenues on R&D, but electronics spend 10%, and pharmaceutical industry spends 13%. So why don't energy companies spend a higher percent? They're too busy, perhaps giving some money back to their investors, and need to think about investing in energy itself more. Level the playing field, reduce green premiums. He's very aware of those. He's mentioned them all through the book, and raise fossil fuel costs. That was just done in England today. Apparently, they lowered the cost of fuel with a special tax for the people flying into Scotland, and many people were quite annoyed about that. So they should have raised the cost, not lowered them. Especially in a country that's small with a very efficient rail system, that was pretty silly to do. Overcome non-market barriers, educate homeowners, incentivize landlords regarding the construction of energy-efficient homes. It's a good idea. Stay up to date. Concrete standards should include low-emission cement, and we need to promote that idea. Plan for a just transition away from fossil fuels. We need innovative leaders, that's for sure. Work on 3 levels to wean us away from fossil fuels at the same time, and they need markets, technology, and policy. You need to read those chapters. I can't summarize them all here. Learn from failed policies that did not keep up with technology, such as the nuclear power industry. I'll show you that in the next slide. Before I go from that, I want to come back to leaders. Plan for a just transition away from fossil fuels. I just heard at an interesting celebration of life meeting that I went to for a very brilliant professor of computer sciences here in Madison. This now deceased dear friend of mine had a son, his eldest son, who spent 20 years in Germany. He happened to tell me after the ceremony that Greta Thunberg, early in her teenage years, when she first started going outside of Sweden, she went to Germany to give a talk. And after the talk, the Green Party took her aside and said, "Don't you dare mention nuclear energy again. If you do so, we will not cooperate with you. We will not support you in any of our marches or anything like that. We will just not work with you at all unless you stop mentioning nuclear energy." I've been sending her emails for quite a while now through Facebook, asking her why she doesn't talk about the nuclear reactors in Sweden. And now I know why. The poor girl realizes that maybe she could affect getting people aware of fossil fuels more effectively if she goes along with the Green Party of Germany. I asked my new friend on Saturday, what's wrong with the Green Party in Germany? They have got 30% of the vote. What's so nutty about them? And he said, they're like religious zealots. They will not think, there's no rational reason he can imagine that's making them this aggressive. And he's very depressed about it and hopes it'll change, but doesn't have any good ideas on how to make them change. I had that in because it's just new information to me and I find shocking, but probably true. Coming to the nuclear industry, destroying a nuclear plant cooling tower in Germany, which just done recently here, seems like a bad idea when forests nearby are being cleared for more coal mining. This individual I spoke to is not only a journalist, but he has some forestry companies, and he's appalled to see these forests being cut down to clear for more coal mining in Germany. Okay, so what does it take for a new reactor? Getting back to Bill Gates, this is his company called Natrium, and he owns TerraPower. It's sort of linked with Natrium. We've talked about this before, and so it is an important way to solve the problems of our 50-year-old Generation 2 light water reactors. He says nuclear fission is the only carbon-free energy source. Since we can use it almost anywhere 24/7. I've highlighted that in green, we've mentioned it before. He says there's no advanced nuclear plant. This is important. No advanced nuclear plant will be built in this country unless the design is validated, the supply chains are established, and a pilot project is built and demonstrated. This takes time. And so he doesn't think we're going to see any in this country. Maybe in Indonesia with thorium from Thorcon, but not in this country. He thinks it'll take a while. Maybe in Canada they'll move ahead, but that takes time and cost, and we may need to modify significantly. And I think there are some signs that we might, the Nuclear Regulatory Commission. He says, once we can deliver clean power cheaply and reliably, we can electrify widely. Now, just for another view outside of the United States, this came by to me from the International Atomic Energy Association. They have an organization called FRAMES, which stands for Framework for Modeling Energy Systems, and that will quantify how nuclear and renewable solar can be integrated, as in Slovakia. Now, that gray area in the foreground isn't water. Those are solar panels. You have to look a little more carefully to see them all angled appropriately for the sun. And they're right next to a nuclear plant. Rosatom, this is a Russian company. They're working with Putin's support, but not financial support anymore. He says, you guys have got to make it on your own. They hope to optimize the synergy between these solar and nuclear systems in long-term studies to reduce carbon emissions. And I'm delighted to see that. Also, I happen to be seeing this funny little thing from Previk, Russia. I thought, what's Previk all about? Well, it's new because they've got quite a sized port there now. And because the Arctic oceans are melting, they can now ship across the Arctic Ocean and around the eastern tip of Asia to the Orient instead of going through the Suez Canal as much of Europe has to do. And so this little town of Previk is coming into the fore. When I looked at the picture, I did a double take and enlarged the image. And what you can see in the background is the same ship that I showed you in previous talks. It is the only small modular reactor in the world. It's a floating one, and it's been built in Russia between 2012 and 2019, and has been operating there for the past 2 years. It provides not only electricity, but 5 times as much heat when needed for local factories and industry. Greenpeace has commented on that. They condemn it as a floating Chernobyl. Trust them. Okay, a plan for getting to zero. We need to quadruple our clean energy R&D. Bet bigger on a high reward project, match R&D with our greatest needs, and so on. You need to read the book if you haven't already, but this is being recorded and you can read these in more detail later. I've highlighted the 8th one, put a price on carbon. I think that the organization Climate Change Lobby is a good one, and they're working hard to try and get that happen here in the United States. Out with the old. And these are some other technologies needed. He's got nuclear fusion at the top of the right column, which is good, carbon capture under that, so on. Down at the bottom of the left column, next generation nuclear fission, zero carbon fertilizer, a lot of good things, important things. Plant and cell-based meat and dairy, we'll talk about that in a couple of weeks. What each of us can do, that's an important one. As a citizen, we can make calls, write letters, attend town halls. As a consumer, we can ask for green pricing on our electricity. We can install LEDs at home. Most of us have done that, I'm sure. Make your next car electric. Try eating plant-based burgers. By the way, making your next car electric, I've deleted that slide, but I did have one on opinions and attitudes. And the incidence of people wanting to make their next car electric in Germany is 3 times higher than in France and the United States. About 10% of respondents said they might make their next car electric. In Germany, it was 30%. I think that's interesting, consider the grid is so dirty and so expensive. I'm amazed. I think they're attracted to electric cars for other reasons than climate change, maybe. Perhaps they like the performance. Anyway, as an employer, you can look to reduce the biggest green premiums. And finally, and this is one of his last statements, I'll put it in red. Appreciate that the world is not as bad as it seems. With optimism, we will learn what technology can accomplish and what people can accomplish as we keep the climate bearable for everyone and preserve the planet for generations to come. I have a friend who saw these slides and read the book I guess he didn't see the slides. He read the book, and he was a bit critical of Bill for making this last thing. He says it seems like he's just trying to sweeten things up and not make a sad book. The book does really get one's attention, but I think this is a perfectly fine ending. I think we need to have some optimism, and I think it's only if we apply this optimism as opposed to giving up that we'll accomplish something. So I give him due credit for that. This is my very last slide. It was a slide that I showed to this same group in March of 2014, 7 years ago. It seems to be just as relevant now, 7.5 years later. The slide says, I don't know if I can get rid of this. No, it doesn't help. But anyway, we agree to sign a pledge on this world leadership that looks a bit like the Titanic. We agree to sign a pledge to hold another meeting and consider changing course at a date yet to be determined. I hope Glasgow is not going to be that kind of a meeting. I have some more optimism than that, but I couldn't resist repeating this slide from a long time ago. So I will stop my slide sharing now and look forward to some questions from you. It's 11:30. I apologize for going so long. Let's start with question and answers. First one is from Lee Gasper Galvin. She says, why didn't the CO2 level drop during the global shutdown in 2020, if indeed mankind has a real effect on CO2 levels? And my answer to that is that it's one thing to shut emissions. You may have missed the basic point that he makes. We need to have our emissions at zero for 100 or years or more, probably, before we will see the CO2 levels drop. Our atmosphere is like a big bathtub, and you can lower the emissions, you can cut them in half, but the CO2 levels will keep going up until we get them to zero. This idea of net zero is sweet talk, but it needs to be reality zero. And only then. So this is serious business. And I'm glad you asked that question, Lee, because it allows me to reinforce that point again. Doug Edwards asks a question. I believe the repair that wind turbines require most is a gearbox replacement. You're probably right, Doug. As is often the case, an industry has developed to do this quickly and efficiently. Our class has been previously invited a UW professor working on alternatives that might avoid not only this repair, but might also avoid most of the material necessary to build turbines. The message is that we can look backwards. We can't look backwards to make progress. You're absolutely right, Doug. I included that slide as a last minute over the weekend in response to a different contributor to the class. And I agree with you that we need to work with wind and solar. And I'm a joiner, not a breakaway individual. So your point is well taken. Any other questions? Let's see. Let's see if there's anything in the chat window. Yeah, I will close this other one. Mike Green asks to the panelists, CNBC from June the 11th, I guess, or something. Oh, the 11th. Anyway, Gates, who is also an investor in nuclear power, told the Nuclear Energy Institute's Nuclear Energy Assembly on Wednesday that the United States needs to strengthen its commitment to existing nuclear power plants and invest in new ones. I heard that too, Mike, and thanks for reminding me of that. Why he didn't include nuclear in the slide you showed or the book you're reviewing is indeed curious. Well, he didn't. What is even more curious is that I listened to an interview of Bill Gates by somebody, I've forgotten whom, and somebody sent me this video. I don't think it was you, Mike, but it might have been. I think it was someone else. Anyway, I enjoyed the video, and Bill Gates was defending his book, not defending it, but answering questions. And at one point in his wild enthusiasm, he said near the end of the presentation that he thinks that renewables, particularly with an emphasis on sinking of solar, will provide 80% of our grid energy in the future. And I was horrified when I saw that, because that's worse than anything I've read in the book or anything that I put in the slides. And I was so bothered by it that I wrote to our previous speaker from last spring, Meredith Engwin. And I said, Meredith, I don't know if you have any connection with Bill Gates, but can't you straighten him out? That 80% figure is off the wall. In some islands, you might get momentary increases up to 50%, but for a country or for a planet, 80% is absolutely wild thinking and indicates that Bill does not understand the grid. Maybe you can smarten him up because you know more about the grid than most of us. And Meredith kindly wrote back. She responds to her emails very quickly. She wrote back and she said she didn't take any pleasure in the fact that she understands the grid. She said, Richard, you overestimate my contacts with famous people like Bill Gates. There's no way I would know how to reach him. And but I said, if you could think of a way, I support it. I then thought of the possibility of writing to James Hansen, and then I declined. I figured that sooner or later somebody will talk to Bill. I'm not sure that James Hansen is the right person, and I'm not even sure he would know how to contact Bill. But if anybody does have a way of contacting him, please do help us all to straighten him out. 80% renewables is wild. And but at least he didn't rule out nuclear. So we have to say that Bill, maybe he's afraid of being considered a show of the nuclear industry, because to my mind, he did not mention it nearly as much as I think he could have and should have in the book. But I still salute him for helping us to recognize the size of the problem. I mean, there is another slide that I didn't bother to show because of the lateness of the hour. But I could come back if you press me for a couple more slides there. But one of them, most important one, is that nuclear energy can be used for so many things besides electricity. Not only desalinating, as I did mention, for California, but for making heat energy, which can be used for so many things, including cement and steel. So there is a great potential there because you have this grid system already set up in the steam plants, already set up around existing Generation 2 nuclear reactors. To make them Generation 4 reactors would be a smart thing to do, because you'd be diminishing tremendously the waste issue, which we've talked about at length, and you could just use some of the existing facilities so that you don't fully decommission. You don't have the whole problem of decommissioning. You just have a far more smaller footprint, more efficient, much greater efficient use of energy and fuel, and that would do the job well. Somebody asks, can you show that last slide again of the iceberg? Well, I don't know if I can, but I can try. Well, let's see if I can go back to sharing the screen. Yeah, there it is. Sure. It's a pretty dramatic image where climate change is the iceberg and world leaders are heading right for it. There's a certain element of truth in it, even though it's a rather depressing slide. Let me see if I can use that opportunity now to go to this next slide. No, I can't. Let me see, maybe I can. Let's try this one. Yeah, this is what I was just talking about. That we have these transformation plants that take the heat not only for direct sources, but through these steam systems to make hydrogen. Hydrogen is going to be an important resource in the future, and certainly a much better way to make it than stripping it from methane, and for water, for desalination, and so on, for industry use. So that's we can recognize fission as our friend more easily if we stop focusing on the downside and start to focus on the potential beyond just making electricity. This is a slide that I deleted from the talk Um, Bill mentioned Hurricane Maria set Puerto Rico's power grid and other infrastructures back some 2 decades. When a typical storm lasts only a few days, its impact can reverberate for years and siphons off money that could be spent on new investments. And if we allowed Puerto Rico, they did have a research reactor years ago that was shut down, and they've never been supported to give commercial reactors. But commercial reactors with many subterranean power circuits could help reduce tremendously this trauma that that island, which is closely affiliated with us, has to withstand every time a hurricane blows by. This is the one about our air conditioning. It's an interesting thing on what's called the Morning Consult. They say that more than half of American users set their air conditioning below 73 degrees, these three ones, day or night. Same applies here. So we tend to use air conditioning, I think, more than we might. I think we'd be quite comfortable at 73 to 75 degrees. And some of us do, but half of us want it really, really low. And that's a bit wasteful, but some people perhaps need it. And this is the slide I mentioned about future EV buyers. In Germany, it's 30%. In Canada, France, United States, and Australia, and Mexico, it's much lower. But hybrids are good. And I think for Wisconsin in particular, you're better off with a hybrid car if you're thinking purely of carbon emissions, because our grid is so dirty. Lee has mentioned many times that you have to look at the entire life cycle of the vehicle, and that electric vehicles don't need so much repairs. They don't have exhaust systems. They don't have transmission systems. And all in all, even with the batteries, she believes that it comes out positive for EVs, and she may be right. But what I'm saying is that the incentive to clean up the grid should be enhanced by the frequent use of electric vehicles. And even if it takes a Tesla to attract people, I welcome it, because that is going to put more pressure on Alliant Energy and Medicine Gas and Electric to build more than just solar panels and wind turbines. That's about all I can put up at the moment, but we need to, through them, put pressure on NRC to get some small advanced reactors, micro reactors. I'm sure in a few years they can start going in. They're apparently planning on doing them in New Brunswick, Canada. They can do them there. They can do them here in Wisconsin. So that is the last of my screen sharing. It's now 20 to 12. Let's see if we have some more questions. Lou Harnish says, in what ways has Joe Manchin seriously weakened our current reconciliation bill? Well, that's a political question, Lou, but it's a good one all the same. And I had heard about Joe a long time ago as supporting nuclear energy. And that's nice. Don't have too many Democrats supporting nuclear energy, but he seems to be doing a lot more than that. And I do agree with you with the implication in your question that he is seriously weakening our reconciliation bill. That's really important to do. And I think his blocking that in the name, partly because he wants to support West Virginia and coal miners and so on, is a tragedy. I think that he's not alone in that. There are others also supporting him. But I think that one way or another, Biden, I have optimism, Biden will find ways to get around Joe. I just have a lot of faith in Biden, and I think he'll do it one way or another. But I'm not enough of a politician to go into answering that question thoroughly. Let's see. We have some other ones. Bill Gates, Lee asks, Bill Gates is not a scientist. He's not really qualified to write about things about which he's trying to appear to be an expert. That's why he imagines in his mind that we could go to 80% renewables. Totally agree with you. Good comment. Mary Jane Curry asks the panelists, how many years, if it's zero carbon dioxide emissions, before the levels would decrease in the air? That's a question I wish I could answer. I think it will be, if we truly get to zero carbon, we might start to see emissions in less than 100 years. I would hope it would be as early as 50 years, perhaps before the end of the century. I'm not sure that we will get to zero emissions by the end of the century. I wish we would. It would be lovely if we did so by 2050, and I'm glad that politicians are getting on that wagon. To make a promise is one thing, to do it is quite another. But I won't be around. None of us, I don't think, will be around in 2100. But we need to think beyond 2100. We need to think to 2200 and 2300 and way beyond. I think we'll survive as a species. I think we'll get our carbon dioxide and other greenhouse gas emissions down, probably down enough by 2100 to see some reduction in levels of CO2. Until then, we will continue to see strong hurricanes, forest fires, and those have within them their own tipping points, as we call them. And that we could get into a runaway situation. So I'm only saying that optimistically. I like to be an optimist. I'd like to see carbon emissions drop before the end of the century, and they might. That's about all I can say. Let's see, do we have any others? Those are good questions. You guys are living up to your reputation. I appreciate your good questions. So it's now 11:45. And I think you've done well to stick with me, those of you who are still out there. Next week, we'll have Neil Alexander's talk. It's the title has changed. And I think it's not going to be talking much, if any, about nuclear. It's going to be talking about attitudes and illusions and delusions. And I think it's going to be a good talk on how we evaluate risk. And I already have the slides. I've seen them. They're not that many. It should be a great vehicle for discussion. And so have your thoughts aimed in his direction next Monday. Then the next 2 Mondays, I'll be talking about the oceans and about dieting. And when we get some more time in those will be much shorter talks. I'd like to propose to you more group leadership and group participation in the spring when we resume in late February. I'd like to see a few guest lectures and lots of group discussion with group leaders from this group, because I know you all have it in you. And I'd like to back off a little bit and like to see your participation more. So I think we can do that, and it might refresh the initial goals and the way we started 10 years ago with this group. So I appreciate your coming, and I look forward to seeing you all next Monday. Have a great beginning of November, All Saints Day, and all the rest of the week, and we'll see you then. Bye-bye all.